This is Pre-Calculus section 4.3 notes on the laws of logarithms. So today we're going to review the three laws of logarithms that we learned in Algebra 2. These are the product property, the quotient property, and the power property. So we say let A be a positive number, A not 1. Let A, B, and C be real numbers with A greater than 0 and B greater than 0. The product property says log base A of A times B is equal to log base A of A plus log base A of B. So basically, if you have multiplication inside of a log, multiplication expands to addition of logs. The quotient property is very similar to the product property. If you have log base A of A over B, quotient inside of a log expands to subtraction of log. So this will be log base A of A minus log base A of B. And then finally we have our product property, our power property. Log base A of A to the C power. You can bring that C power in front of the log and it becomes a coefficient of the log. So C times log base A of A. So those are the three properties that we're going to be using, and we're going to practice evaluating, expanding, and condensing using those properties. Our first few examples are to evaluate each expression without a calculator. Well, what I notice here is we have log base 6. Log base 6 of 9 plus log base 6 of 4. Since we have the same base, we can use the product property and say that addition with the same base can condense to multiplication. So we can write this as log base 6 of 9 times 4. Then we know 9 times 4 is 36. So we can write log base 6 of 36. And then we can think about this as an exponent. Log base 6 of 36 is asking 6 to what power is 36? And we know that the answer is 6 squared is 36. So this expression simplifies to 2. In the second one, we can use the power property to begin with. We can take that exponent of 7 on the 81 and we can bring it out in front of the log. So this will become 7 times log base 3 of 81. And then that log base 3 of 81, remember that's just equal to a number. We have to think of it as 3 to some power is 81. What power is it? And we know that that power is a 4. So then that tells us that we have 7 times 4. Final answer is 28. Then the last one, we're subtracting two logs with the same base, so we can condense that using the quotient property back to division inside of the log. So this is going to be log base 2 of 5 over 40. 5 over 40 can then be reduced to log base 2 of 1/8. And then once again, I need to think about this in terms of exponential form and say, well, this expression is going to be equivalent to the exponent on a 2 that would turn 2 into 1/8. And as we know from our previous work with exponents, to make a base into a fraction, you need a negative exponent. So 2 to what power is 8? That's going to be 3. And if I want to move it down below the 1, then that means that the answer here has to be -3. These are great problems because they force us to tie logs and exponents together, to use our brains, all that stuff. In the second set of examples, we're going to be using the laws to expand each expression. Okay, so we're going to start with the fact that inside of our log we have a 24 and an m cubed. Okay, we can't do anything with the power property until we separate the 24 from the m. So the first thing that I'm going to do is use the product property and expand this log into the addition of two logs. So this is going to become log base 5 of 24 plus log base 5 of m cubed. Now that I've done that, the next step that I can do is now I can take that 3 and I can move it in front of the log. So the log base 5 of 24 doesn't change, but then I have plus 3 times log base 5 of m. And that's going to be my final answer. My second equation, or excuse me, my second expression, I've got multiplication upstairs, I've got multiplication downstairs. So I have to consider how many bases I have inside this log. Q is a base, W is a base, 4 is a base, and T is a base. If I have 4 bases, then when I expand this out, I am going to have 4 logs. Now keep in mind the bases that are upstairs in the fraction, those are being multiplied, so those are going to be positive when I expand. The bases that are downstairs are also being multiplied, so we're adding those together, but anything that's in the denominator, because this is a quotient as well, is going to be subtracted. So first I'm going to start by just separating the top from the bottom. I'm going to take this in multiple steps. So if I separate the top from the bottom, this is going to look like natural log of q to the 7th w squared minus natural log of 4t. But now I can take each one of those and I can split them apart. So this can expand to natural log of q to the 7th plus natural log of w squared. I still have this minus sign, so now I'm going to need parentheses because anything that I do after the minus sign needs to get subtracted. So then inside the parentheses I've got natural log of 4 plus natural log of t. Now for my next step, on the left side here, I'm going to take these exponents and I'm going to bring them down using the power property. So this is going to be 7 times natural log q plus 2 times natural log w. And then for the second part of my expression, I'm going to go ahead now and I'm going to distribute that negative. So then I'm going to have minus natural log 4 and minus natural log t. And that is going to be my final answer. In the third set of examples, I'm going to be doing the exact opposite. I am going to be trying to expand these expressions back. So when I'm done, I should have 1 log. Right? When you are done, there shall be only 1 log. So let's see if we can accomplish this one step at a time. All right. The first thing that we're going to do is if there are any coefficients in front of the logs, we know because of the power property that those were exponents. So we need to restore those back on. Okay, so this 4 has to go back on the w, the 1/3 goes back on the n, and the 5 goes back on the k. So this is going to look like log w to the 4th plus log n to the 1/3 minus log k to the 5th. Now, because I don't see a base, remember that it's the common log, so these are all base of 10. So now I'm going to be able to combine these using the product property and the quotient property. Well, I know that since log w to the 4th is being added to log n to the 1/3, that those two are going to be condensed together in the numerator. So it's going to be log of, and then upstairs it's going to be w to the 4th n to the 1/3. And since we're subtracting log k to the 5th, that k to the 5th is going to be in the denominator. And I can just leave my answer just like that. I condensed it down to 1 log. In my second example, looks like I have some exponents that need to get restored, the 5 and the 2. So that's always going to be my first step. So I have ln of x minus 3 minus ln of x squared plus 1 to the 5th power plus ln of x squared. Okay. And now I have to take a look at what is positive and what is negative. Anything that is positive, these two terms, are going to be upstairs in my quotient, and anything that is negative is going to be downstairs in my quotient. So up and down and up. We all have the same base here. It's all base E. So I'm going to go ahead and I'm going to condense this down to one log right away. So we're going to have natural log. We're going to have a quotient here. Upstairs, we're going to have the x squared and the x minus 3. It's multiplication, so order doesn't really matter. And then downstairs, we're going to have the x squared plus 1 quantity to the 5th power. And that is going to be my answer. I've condensed down to one log on both of these. One more example here, which I don't believe that you have in your notes. If you'd like to add it, you can. If you want to just watch for fun, that's fine, but I'm going to go through it. So in this example, we're going to restore our coefficients into exponents first. So we're going to have log x minus log w squared minus log y cubed. Okay, and then I'm going to do the same thing that I did in the previous problem. This term is positive, so I know it's going to be upstairs in my quotient. And both of these are negative, so I know that both of these are going to be downstairs in my quotient. All of my bases here are a 10, so I'm ready to go ahead and condense to one log. Upstairs I have x, and downstairs I have w squared and y cubed. And that's my final answer. The next thing we're going to talk about is the change of base formula. Because our calculator can only calculate log base 10 and log base e, sometimes it's useful to change the logarithm from one base to another, especially so that we can do a calculation on our calculator. So let's say, for example, that we have log base b of x, right? So if we want to let our base become 10, notice that the base goes on the bottom, okay? The x goes on the top. So if we let our new base become 10, then this is just going to become log of x over log of b. If we let our base become e, then this formula just becomes ln x over ln e. But if we had, ln b, not e. If we had, actual numbers here that we were working with and we plugged these in, the x and the b, then we would get the same answer whether we did log x over log b or whether we did ln x over ln b. They will yield the same. And we're going to test that right now with the next two examples. In example 1, we have log base 6 of 41. So if I use the change of base formula and I use a log base 10, then I would write this as log 41 divided by log 6. If I used a log base e, I would write this as ln 41 divided by ln 6. Either way, you grab your calculator, and both of these give you the same answer when you type it in, which is 2.0726. We often like to go out 4 decimal places when we're approximating logs. In example 2, we've got log base 7 of 2. So again, we could write it with a log base 10 or with a log base e. With a log base 10, this is going to be log 2 divided by log 7. With log base e, this is going to be ln 2 divided by ln 7. But either way, we type it into our calculator and we should get 0.3562. If you're having any trouble with change of base formula, please see me so we can help you get that figured out.